Hi. Just before we move on to part 7 of this adjustable lab power supply, I wanted to bring up a note about the way I routed this PCB, because it is actually really strange. Although I did do it at 4 o'clock in the morning, that could be why. Now over here at pin 7 of the op amp, that goes through this trace here, I believe. Can't really see because there's parts in the way. Yeah, it goes off from pin 7 here, up here, and goes to, well, the base connection of the TIP36C. And then this resistor here, which is part of the shunt regulator circuit for the 5.5 timer, which is out of shop, that comes up here, goes up next to the same trace to the positive of the capacitor. Now, or the main filter, both of these routes go to the same place. So I've got two routes which connect to the same place next to each other. And one goes off that way in a straight line and one goes off that way. Why didn't I just join them together? Anyway, that's what happens when you do stuff at 4 o'clock in the morning. Okay, and just so it's clear for everyone else, here is the actual CAD file. That part of the TIP36C, by the way, is the emitter, not the base. I got the pins mixed up. That's neither here nor there. This is the main filter cap, so that goes into the emitter. We can see a route going off here under the relay, going off to pin 7 down here of the TLO71. And we've also got a route coming from the 1K3 resistor and the BC546, part of the shunt regulator circuit, going next to that route back to the same point. Why did I do that? It makes absolutely no sense. Anyway, on with part 7. Greetings, the Astro 30 here yet again with another video on this variable power supply. Now today we're going to look at mounting a TO220 fin heatsink to the BD139 shunt regulator transistor to keep it from overheating. We're also going to look at putting in a load switch so I don't have to short this connector here like I am now, so I can turn the thing on and off. And also looking at the display panel meter that's going to be going on the front of the case. So all that coming up now. Alright, finally, after a little bit over a month of waiting, I've received the blasted TO220 fin type heatsinks that I've ordered. I think that deserves a beer. Well, it is the end of the day anyway. Alright, let's see what we got here. There we go, nice. Yeah, it appears to be 10 of them. I thought I only ordered 5. These are the ones I was talking about that JCar no longer sell. They are 15mm across, I believe it's 19mm high, and we're talking about 10mm deep. So they finally arrived. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, okay. So that will fit. Oh, just perfectly. It clears everything. It'll fit just on there nicely. Okay, so I'm going to apply a small little bit of heatsink compound to the back of the transistor if I so can. Doesn't take much. Here we go, that should be just enough. And I've just dropped the screw on the floor. For f***'s sake. I have no idea where that went. Keep rolling off, find the bastard. Where did I drop it? Well, if I knew that, I'd be able to find it. I found it. Right in the corner of the room. Of course it is. Okay, let's try that again. Pass the screw through the transistor. Probably a bit longer than necessary. Put my heatsink on. Grab my nut. These nuts. Now it doesn't really need isolation because it's not coming into contact with anything else in the circuit, and my fingers won't work for some reason. Come on, oh you bitch. Thank the Lord for magnetic screwdrivers. I might try this a different way. I'll just hold the nut and turn the screw until it lines up and threads. There we go. Probably the disadvantage of having a long screw. I'd love to have a long screw actually. Okay, well this is going to be fun to keep that heat sink straight whilst tightening the nut. But I'm applying a little bit of back pressure to the heatsink so it doesn't move, and there we go. This power supply unit now has a heatsink on it, and for all intents and purposes it could actually face the opposite way too, but I'm quite satisfied with the way that is there. I went to JK and got another one of these type of switches. It was the SP0704. And this should work just fine for the low DC requirement for this load switch. It's only 12 volts going through it, so that should be fine. And I'm also going to make use of the indicator LED. And it's not a momentary, there is two types. Right, so first I'm going to remove this shorting wire. Don't need it anymore. Excuse the noise, there's some kids walking from the school on an excursion. Next I'm going to install this 2-pin header into the LED spot with the load on. The cathode looks like it's on the left of the connector, which is good. This is an awfully odd angle to work out. Just want to get one tacked in at least. Okay, it's nice and straight. So I can solder it properly now. Okay. So I've got a bunch of new wires too, and I'm making them about 25 centimeters long, brown, blue, black and red respectively. I'll just use scissors for this. There we go. Heat shrink just fits. Alright, the heat shrink just neatens it up a bit. Beauty. Right, there we have it there. I spared you the pain of doing these sodding JST connectors because they are a pain in the arse. Now, I just need to neaten up the wiring by putting cable ties around it, plug it in and testing it. Oh, lost one. Where'd you go? D and switch. Let's see if this switch indeed works. Gravity. Alright, got the multimeter across the output to see what voltage we got. I think it's still set at 9 volts somewhere. Alright, so I'll plug it in. Hey, I even got the switch around the right way. I'm in the LED. And there we go. We've got an output voltage. Now we don't. Now we do. So I want to see if this is still zeroed. Yep, still zeroed. Beauty. There we go. Now we can move on to the panel meter section now, so we don't have to rely on a multimeter to see what our output is. Great, that means more wiring of the sodding JST connectors. Brilliant.
Mr. Penis.
Finally, after about 3 weeks of waiting, the panel meters have turned up. And I didn't order them from China, I ordered them from Australia. So it cost me probably twice as much from Australia, but it doesn't really matter. But I should have just ordered them from China. Would have taken the same amount of time to get here. Anyway, they're here now. So I'm glad to see them. So I will just open the package. The thing is, the wires on these are going to be too short, so I'd have to redo the connectors. I'm just going to open up one, and I do have, that didn't work, I do have a set of JST connectors for the job, these ones, so I can easily change this one because these wires are just going to be way too short. Same as this one's going to be way too short. The connectors I use probably won't fit in this situation because it's got a different sort of clip on it. Okay, so I'm going to have to go to plan B with that idea, and that is I'm going to have to probably attach some wires to the ends of these and extend them. Well, that wire would probably be long enough to go out to my load socket, which would be right next to the meter anyway, so I don't have to change that one, but I do have to lengthen the current sense wire. Anyway, this connector I should be able to replace because I've got a bunch of them here, as we can see, which they look, well, this one's slightly shorter on the left here, but they look physically the same. So if I pop that in there, perfect. Yeah, I can change that connector fine. This one I'll have to just lengthen the negative wire, which is not something I wanted to do, but it is what it is. So the way these work is you've got your positive and negative voltage coming in. That's the supply, and this is what you measure the current through. It comes in the black wire on the common, comes out the red wire to your common output. Now, if this meter is powered off the same common rail supply as what you're measuring, then you do not connect this black negative wire to anything, you disconnect it. So if you're going to use one of these meters, you can just simply pop this whole entire part out of the connector. This is the sense wire for the voltage, the yellow one. So that's basically all you need. So now I want to test to see if this meter actually works, upside down. I want to test to see if this meter actually works. So I'm going to power it up. Alright, so I've got a DC supply, 9 volt plug pack sitting here. So I'm going to connect up how it's going to be configured in the actual project with the negative common going into there. Make sure those two don't short. Which means I need this positive wire over here. If it would make good contact, that'd be great. There we go. As we can see, it's actually lit up. And if I touch the yellow wire to the voltage supply, 1.2 volt. So I don't know how accurate that actually is, but I reckon it'll be close enough. So in order for this to work, as I said, I'm going to have to lengthen the wires on the low side here, and at least lengthen this negative wire. Alright, so to measure the current, what I'm going to do, or actually check to see if the current measurement works, so I'll connect where the common would normally go across this 10 ohm 5 watt resistor. I don't know how much current that's actually going to draw, and I'll hook it to the positive. We're looking at 830 milliamps thereabouts. I don't know how accurate that is. How much did the voltage drop when I did that? Okay, 8.6 volt is what it says. So we can confirm that 8.6 volt divided by the resistance gives us the current of 860 milliamps. And this is saying 830. So it's not that far out. Okay, now what I want to do is I want to test the second meter to make sure that that's working, and then we can move on with our lives.
There's my pussy to consider.
So we got the second meters powered up. We'll just check the voltage. .2 roughly. Check the current functionality. About the same, 830 mA, and the voltage reading now should be 8.6. So the 2 meters are pretty much calibrated roughly the same. You can calibrate the voltage at least on this, but you can't calibrate the current by the looks of things. There is a little voltage calibration pot here, but there isn't a current one. So the other older version of this I used did actually have a current adjust, but this is only just a voltage adjust, which is annoying. I think the other one's exactly the same too. Yeah, it's only a voltage adjust. So, oh well, at least I can change this connector and this connector to make the wires long enough. So anyway, I'm happy to see these meters. I'm glad that they're here now. That means that this project is one step closer to being complete. So for now I'm going to put these away until I actually have a chance to redo the connector and I actually have a front panel to mount them on, because, well, there's no point having them floating around. I don't need to connect it up to the power supply unit yet. That can be done in final test. I'm pretty sure that it'll power it just fine. So yeah, I'm going to put them away and we'll move on to something else. Alright, and something that's important to this project has just arrived. Let's open it up and we'll have a look. Should be 2 of those. Indeed. These are 10-turn pots. This is going to be used for the voltage selection, and I'm actually glad to see them. They don't have the veneer, but it's nice and smooth. Right, so it is marked on here. 1, 2, 3. So 3 is the clockwise position. So this position here is when you've rotated the pot fully clockwise. That's the sensor tap, or the wiper, and that's the counterclockwise position. So we can verify that with a multimeter. Right, these actually arrived yesterday. I've only just got around to looking at them today. Now I've lost my other lead. So hopefully these don't short. Okay, and currently it's saying 10.42 kiloohms. So that is at its maximum clockwise. So if I start winding it backwards, well, that doesn't appear to be doing much. So I'll try it there. There we go. We're now at 0 ohms, it's stopped. Well, 0.7. And as I increase it, the resistance increases. So that'll sit there in the corner of the room gathering dust and pubic hairs. Now, it would help if I read the pot correctly. This far outer lead, I mean, if you really examine it closely, you'll notice that it's about 1.5 millimeters different in pitch compared to these two pins. So this is the common, or the wiper. This is the counterclockwise connection, and this is the clockwise position. So if we connect the multimeter correctly to it, which is one there and one there, and then we rotate our pot, we can see on the meter the resistance is going up. Conversely, if we now take this black lead that's now connected here and connect it to this other pin and wind the pot in the clockwise direction, you'll notice the resistance is coming down. See how the resistance is coming down? So I now know how that is supposed to be wired. So to recap, where this red wire is the wiper, or the center of the pot. The pin next to it is the counterclockwise pin position, and the one closest to the front of the pot is the clockwise position. Biddy, so now I know how that pot works. I can wire some wires up to it to connect to the power supply module to get, for the voltage anyway, to get a more precise, well, semi-precise voltage adjustment. So it's not so finicky when you're trying to get, like, 1 volt, 1.2, 1.5 volt out of it. Using a normal single turn pot, that makes it next to impossible to get it very close. This will help a lot more. Something dark side. Something complete. Alright, for this adjustable power supply project, I do actually have the case that I was planning on using. It's a HB5910 and its measurements are 253 by 190 by 82. So now I need to determine whether or not all my components, that's 2 modules plus a transformer, is going to fit inside this case without too much issue and still have enough clearance at the front for the front panel controls and stuff. So, but first I need to go to the toilet and take a dump. Much better. Now I've had this case sitting around for the best part of 2 weeks until I was ready to actually look at it. I'll leave the screws in the bag. And currently it's upside down. So that's the bottom. Now, I'd like to make that the front, I suppose. Now the idea with this was that I was going to take one of these panels and cut out a metal aluminium panel the same size. I was going to take one of my modules and actually mount it to that said aluminium panel, just up a bit, on the rear of the case with the heat sinks on the outside. That way there's less heat build up inside the case because you've got the transformer as well. And I was thinking that these leads would be too short, but they might just be long enough to reach it from this module to the front, so I don't have to rewire them. The LED is going to be too short, so I have to rewire that, but that's alright. Now, I was thinking I might have to cut some of these tits off in order to accommodate the transformer. I might still have to, but it's only a couple. Because I just want to see if there's going to be enough room at the front of this case to give me clearance for all the connection thingies, like the meter and stuff. So if I put this in, which is back to front, which doesn't seem to fit for some reason, okay, that's interesting, it doesn't fit. Maybe it's just a little bowed, I don't know. Because I don't know how long this case has been sitting around for, but yeah, I just need the second module, because that's about where the back is, where that bracket is where the back panel is. So I can't move that module back any further. So I just need to get the second module in there so I can actually look at this a little bit better. Second module is sitting there, incomplete, but it's in there. So, well, that transformer can come back probably another 10 mil easily without interfering with the circuit boards. So I'm left with a gap of, I don't know, 25 mil there. Take one of these pots. It just clears it. Just clears it. And the body depth of the meter that I'm going to be using is about the same depth here. So it'll just fit. It's going to be tight, but that's the only solution I've got, is to mount that transformer up the front. As for clearing all these ribs and stuff, yeah, that might be another issue. I might have to get a Dremel tool to cut that crap off, or grind it down I should say, but I want to just check that the lid fits on. It looks like this case has been sitting around for a while. Because it doesn't seem to fit together all that great. I'm wondering if the transformer's not clearing. It's clearing. But yeah, I'm not sure why this case doesn't fit together properly. It's a bit weird. Okay, I don't know how well you can see that, there's a wire in the way. It is clearing the top of the case. I'm not sure exactly why the case is not fitting together. I'll just take the transformer out just to eliminate that maybe that's the clearance issue. Although these wires are probably getting in the way of the post. So let's try that again. No, it just does not fit together very well. I don't know why. It should, I mean, unless I'm putting this together backwards, it shouldn't matter which way around you put it. And actually, apparently it does. Okay, well, fair enough. So, interesting. Let me take that one out because that's tight as anything. I do not like how these panels just do not fit properly. Anyhow, I'll put the transformer, I might actually disconnect these things because they're not really needed right now. They're just in the way. I'll put the transformer back in, roughly where it's going to sit, and I'll put the lid back on. Nice, clears it just fine. Perfect. I think I'm going to have just enough room inside here to mount all the gear. Alright, so what I've got to do now is have a front panel made. I have measured what the panel dimensions are, but it is awfully tight in this case, and I'm going to be having the front panel manufactured out of PCB material. So that's going to, I don't want it to flex back and forth like that when trying to get it in, because it might break it. So I might actually change the dimensions by a couple of millimeters on either end, just to make sure that this will fit together properly. I mean, this lid should fit on there properly, which it does, either way around. Shouldn't matter which way around you put it. And no, it doesn't. So there's an issue with these panels being just way too tight. The height is correct, up and down, the width is not. So I'd have to make the width slightly smaller, which is okay. So in order to connect my transformer up from the line cable or an IEC socket, for instance, to the transformer without having to use a terminal block, I came up with the idea of making a adapter board, and this is what this is. There's the product number code there, W3831668SZ17. It's a single layer, and I'm just interested to see what single layers PCBs from PCBWay look like. So I just open the bag and I pull one out to have a look at it. So, yep, here we go. So the idea is active and neutral come in from the IEC socket here via spade terminals. It then goes through a switch which goes to the front panel. There's a 22 nanofarad 50 volt AC X2 capacitor here to across the switch contacts to stop any pops and clicks when you turn it off. And then this then goes out to these two connectors, which have the ability of connecting two transformers to the same power switch. And it saves the issue of using a terminal block and putting a wire in, screwing it up, and then having wires going in. Terminal blocks are fine, but I wanted a more easier solution, and there's the underside. Now, those tracks are only 3mm, I believe, so yeah, current capability of this would be pretty limited, so you wouldn't put this on a large 500 V8 toroidal transformer or anything. It'll work for up to, I reckon, 3 amps should be fine going through that. But that's what that is. It's a little power board adapter. It's quite cute, actually. That's been sitting in my PCBWay account for months, waiting to be paid for and made, but yeah, I never got around to doing it because, well, I had other things to do. And I've been busy. I've done a little bit of hardware wiring. I've got the switch PCB, which I talked about, mounted in here. Now it currently only has 2 standoffs because I don't have enough of the 6mm long screws. I'm going to have to get some more, and that'll be finalised a little later anyway, because I need to take all that back out again anyway. Why? So I can cut off or grind down those ribs where the transformer's sitting there so it mounts flat. I have marked roughly where the transformer's going to go. I haven't drilled the holes yet. Got the power switch wired in, that goes over to here. So now I'm ready to test whether we've got continuity to the transformer. So currently the switch is off and we've got open load. Turn the switch on and we have 21.6 ohms there roughly.
Isn't that special?
Right, that's on, that's off. So now I should really test whether or not it can switch the AC. It should be able to. This PCB that I made is probably good up to 3 amps of current going into the transformer, but it shouldn't be drawing any more than that anyway. Alright, I've got to figure out how I'm going to do this. Okay, I've got kind of the dodgiest setup here. I've got some jumper wires across the line cord. Don't do this at home. And here's why. Hopefully nothing happens. Ooh. Because if you f*** up, that can happen. I don't know if that worked or not. Oh yeah, it's working. I've got the load switch on, see? Disconnect that so it's safe. Alright, so I know that power switch will switch that transformer fine, and I didn't hear any, what's it called, inrush current going into the transformer, but oh well, that's good. So I'll just remove this dodgy setup. So yeah, it works. Now I can continue on with the wiring, like the LED to the PCB and stuff. But for now, that's about all I'm going to do to it. Because I need to rework that case of the transformer mounts flush to the plastic. I also need to have a front panel made so that I can start actually assembling this properly. And I'm going to come up with a proper line cord to go in there. It'll, with the aluminium panels going across the back here, the line cord will come in here through a strain relief clamp. It'll come up to the front here into this PCB and through a fuse, and then off to well, the transformer as it is now. And of course secondaries going off to the PCBs, and that's basically it. So I'm going to leave this part of the video here, and the construction will be picked up in part 8 once I've got a front panel. So anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook, and you can also become a Patreon member for as little as $1 a month. Anyway, this is the Astro 30 saying see ya. Thanks for watching, guys.